8th grade StemScopedia, changes in force and motion. Reflect. Bong! That's the sound of a pinball hitting a post, bouncing off, and hitting another post. The pinball constantly changes speed and direction as the force of mechanical flippers propels it in different directions and at different speeds. The motion created by the forces in a pinball machine is simple enough. Yet there are many forces that act on the ball as it bounces from one post to another on the slanted pinball game board. Are all things in motion affected by the same types of forces? Forces can cause a change in motion and direction. Motion, the change in an object's position with respect to time and in comparison to the position of other objects used as reference points. When an object is not moving, its potential energy, stored energy, is at its greatest. When an object is in motion, potential energy is contained into kinetic energy. Energy changes from potential to kinetic when a force is applied. The force can be gravity, your legs pedaling a bike, a batter hitting a ball, etc. Forces can result in the change in the speed or direction of motion. All changes in motion require the input of a force. The simplest way to think about motion is a change in position. If you ride your bicycle from your house to school, you have changed your position through motion. The force of pedaling the bicycle causes this change. Your speed, rate of motion, is based on the distance you cover in a specific amount of time. You also bike in a certain direction. If you turn left at an intersection while riding your bike, you have to apply a force to change direction. As you approach a stop sign, you slow to a stop and then speed up again. Speeding up and slowing down are also changes in motion caused by force. Any change in the speed or direction of a motion is called acceleration. Page 12. Newton's second law of motion explains the relationship between force, mass, and acceleration. The relationship can be shortened to a mathematical formula commonly known as F equals ma, or force equals mass times acceleration. F is force measured in newtons, mass is measured in kilograms, and acceleration, change of velocity, measured in meters per each second squared. Force is measured in newtons. 1 newton is the force needed to change the motion of a 1 kilogram mass by 1 meters per second in 1 second. Think of acceleration as a change of motion. Acceleration is a change of velocity of an object that slows down, speeds up, starts, stops, or changes direction. Newton's second law identifies that the net force causes change and the mass resists change. Note, force equals net force, or sum of all forces acting on a body. You can also rearrange the equation to focus on changing acceleration. A equals F divided by m. Another way to think of Newton's second law of motion is to understand that acceleration is caused by a force and is proportional to force. Greater force causes greater acceleration. Acceleration is inversely proportional to mass of the object. The greater the mass of an object, the more it will resist any change in motion, i.e. acceleration. Considering these concepts, answer the questions below. Why do you think it is harder to push the car in picture A than it is in picture B? Explain. What would allow more acceleration in picture A? Key concepts about Newton's second law of motion. The acceleration of an object is determined by the sum of the forces acting on it and the mass of the object. If the total force on the object is not zero, it will accelerate in the direction of the net force. If the net force is zero, the object will not accelerate but will continue in its current state of motion. The greater the mass of the object, the greater the force needed to achieve the same in motion. For any given mass, a larger force causes a larger change in motion. When mass of an object increases, acceleration decreases. When the force on an object increases, acceleration increases. Reference frames are important. For motion to be described precisely, you need to use a point of reference, which is just a position that is not moving relative to the object. The motion of an object can often be described differently depending on the frame of reference. For example, a person walking toward the front of a subway car may be walking 1 meter per second relative to the passenger sitting still in the train car. But if the train is moving 13 meters per second, that same person is moving 14 meters per second relative to the ground outside the train car. Motion is relative, which is why it must always be described relative to a frame of reference. First, describe an object's position relative to some fixed reference point. Position is the place in space that an object occupies in some coordinate system. Next, describe the distance the object is away from a reference point and the direction relative to that frame of reference. For example, the speed of a bus compared to a relatively still object like the bus station, or the speed of Earth as it orbits compared to the relatively stationary Sun. Motion cannot be described accurately without first establishing a frame of reference and a reference point. The stationary spot from which you are doing the measurement is called the reference point. Motion is described as a change in position compared to a reference point.